Welcome to Study Loop.
For our situation, we know P is equal to 10 centimeters, N1 is equal to 1, and I is equal to negative 13. And it wants us to find N2. So we're going to start out with the equation N1 over P plus N2 over I is equal to N1 plus N2 over R, where R here is equal to 2.5 times the distance to I. So we end up with 1 over P, because we're just going to replace N1 with 1 to simplify. So 1 over P plus N2 over I is equal to N2, because N1 plus N2 would just be, N2 plus 1 divided by R, which is 2.5 times I. So in other words, we can solve for N2. So we find that N2 is equal to N2 plus 1 divided by 2.5 times I, which is equal to, N2 plus 1 divided by 2.5 times I minus 1 over P all multiplied by I, right? So we can further solve for N2. So what we end up with is N2 minus M2 divided by 2.5 is equal to I divided by 2.5 minus I over P. So then we can go ahead and further solve for N2, because we're going to pull N2 out of the left side of the equation. So we end up with, and we'll go ahead and start a new page for this. So again, we're pulling N2 out of the left side of that equation. And we end up with N2 is equal to I divided by 2.5 minus I over P. And then this whole thing is going to be divided by, because we pulled N2 out of the left side of the equation, 1 minus 1 divided by 2.5. So we find that N2 here is equal to 1.5, which we can box in as our solution for part A. Part B says what is P, but that was just given. So we can just simply say that P, if we go back to what was given, P is equal to 10 centimeters. Part C says what is R, but again, R is equal to 2.5 times I. So here, R, then if R is equal to 2.5 times I, then R is equal to negative 32.5 centimeters. And the reverse is true, but we're also given it. But either way you want to do it, you could say that I is equal to R over 2.5. Or just go with what was given, because that would be kind of circular logic, but it would be equal to negative 13 centimeters. We can box that in as our solution for D. Part E says, is the image virtual? And it wants to know if it's virtual and if it's upright. So the image is virtual because I is negative. So we can say, since I is negative, the image is virtual, right? And we want to know if the image is upright. So we can say, well, to do that, we can look at the magnification. So magnification equals minus I over P. And negative I over P is positive. It's a positive number. So this is equals some kind of positive number. So upright. Right? It doesn't matter what that number is. All we need to know is that it's positive, and therefore it's upright. So we can box in upright and virtual as our solution to E. And then lastly, part F, it wants to know if the image is on the same side or the opposite side. But we have a virtual image, so that means it's on the same side for the lens. And we can box in same side as our solution for part F.